right, today we are on 315. Our last day on systems. Yesterday we did graphing and substitution. Today we are working on elimination. Probably, I would say this one's my least favorite one of the three. But it can be very useful in some situations. So for instance, this first one, solve the systems using substitution. So substitution is usually my preferred way. And I'll show you why it's not the best way in this one. So I'm going to isolate for one of my variables. Not any single one of them particularly stands out to me like, yeah, this is a good one to solve for. So I'll just pick the first one. I'll solve for x. So move no, the second one. Just kidding. Ignore my comment originally. Okay. I'm going to choose the second equation, solve for x, just because the numbers are a little bit smaller. So I subtracted 4y to both sides, and I will divide everything by 3. Okay? Then I will take that and plug it in for x up here. All right, so notice that this negative 15/3, I did reduce it down to -5 here. So that's how I got that. But otherwise, I just plugged everything in for x, making sure that I used my parentheses because it's -3 times everything that x is, and x is -5 minus 4/3 y. Okay, now I'll distribute that -3. And I get 15 plus 4y plus 7y equals -51. Combine like terms, subtract 15 to both sides, and divide by 11. And so now y equals -6. And then I take that -6 and I plug it back in for one of my y values to find the x value. I chose the second equation. Why? Because the numbers are a little bit smaller, maybe easier to work with. I don't know. So 4 times -6, -24, add 24 to both sides, and divide by 3. So then the solution to this system is 3, -6. X is 3, y is -6. Okay, why was it so time consuming to use substitution? Like, what extra step was involved here? And the answer is that I had to isolate a variable, and then I had to deal with fractions. And while it did work out kind of nicely that the fractions weren't too big and the fractions didn't stick around once I distributed that -3, turned into a whole number, but it could have potentially been quite a dangerous problem if those fractions had stuck around. I would not have been too thrilled to solve that. So in some instances, elimination is the better method. So here's some examples if you don't remember if you don't remember elimination. Here's some good examples to work through. Otherwise, I'm just going to head right down to this second example here. We'll solve by elimination. So I'm trying to get a variable to cancel out. So what do I need? I need the same number with opposite signs. So thankfully, this one already has the same number with opposite signs, -12 and +12. So I can add these two systems together. Just write them, add them together, and when that happens, the y variable cancels out. I'm left with 25x equals 375. Divide by 25, x equals 15. Okay, going pretty fast so far. Now I'm going to take that x variable and plug it back in for x, one of those two equations, probably the first one because those numbers are smaller, to solve for y. So plugged it in. 8 times 15 is 120. Subtract 120 to both sides and divide by -12, so y equals 1/2. X is 15, y is 1/2, and that is my solution. And remember, a solution is just where those two lines intersect. It's the number that they both have in common. Okay, so that one did go quite a bit faster than substitution. So substitution is not always the best. But yeah, okay, moving right along. Now, sometimes we notice we don't have the same number with opposite signs. I have opposite signs, but not the same number. So I have to manipulate one of the equations so that I do get the same number. So they multiply by 4, in case you missed that. Okay, so next one, I notice I don't have any of the same numbers. I don't even have opposite signs. Okay, so let's pick the smallest number and see if we can change it into a bigger number. So 20 and 17, I'm not going to deal with those. 12 and 2, yeah, I can make I can make a 2 into a 12 pretty easily. I don't have opposite signs, so I'm going to need to multiply by -6, because -6 times -2 will give me a positive 12, and that's what I need in order to do elimination. So I'll rewrite the first equation, nothing changed there, and then I'll distribute that -6, and I do get some pretty big numbers, but hopefully they go away in the end. Okay, so those -12s are going, the -12y plus 12y is going to go away, leaving me with -82x equals -410. Divide by -84, and x equals 5. Nice small number to work with. Okay, take that x variable and plug it back into one of the x equations up above. 17 times 5 minus 2y equals 95. Multiply, subtract 85 to both sides, divide by -2, and y equals -5. So my solution, where they intersect, the point that they have in common, is 5, -5. Okay, moving on to the next one. Now notice those numbers got quite big. This one, again, I don't have the same number, opposite signs. I'm definitely not going to deal with 30 and 24. That's not going to happen. But the 5 and the 4, I could multiply the top by 4 and the bottom by 5, but I'm going to get some pretty big numbers, and I just don't like big numbers. So let's see if I can actually, instead of multiplying, let's see if I can divide out like a common term or a common factors to see if I can make those numbers smaller. So in this first one, it looks like they're all multiples of 5. And in the bottom one, they're all multiples of 4. And if I do that, divide the top by 5, or top by -5 and the bottom by 4, then what happens is I get -1 and +1y. Now, look how nice and easy those numbers become. So easy. Okay, so when I go through and I add these, I actually get 0 equals 2, because 6x and -6x cancel out. -y plus y cancels out. I'm left with 0 on that side. So what does this mean? Well, 0 never equals 2. Ever. Ever, ever, ever. So this means that there is, in fact, no solution. These two lines would be parallel to each other because they have no points in common. No x variable, no y variable. Okay. Moving right along. Last one. We're going to solve by all 3 methods. All right. Graphing, substitution, and elimination. A little bit time consuming, but it's the last problem we're doing. So let's go for it. So to graph, I need them both in slope-intercept form because that's just easier. So solve the bottom one for y. I subtract x to both sides and then divide by -1 to everything. So y equals x plus 2. And then the top one, I flipped it around and then added 8 to both sides. So hopefully you followed along there. And then divide everything by 2. There we go. I can graph both of those lines like that. So you know how to graph lines. Just find the y-intercept, and then your slope is rise over run. And then the solution is where they intersect. Notice I didn't draw my lines totally perfect, but I can kind of guess that it's maybe at -4, -2. And if you're like me and your lines aren't totally perfect, there is a lot of room for user error in this one, just because if your lines aren't perfect and straight, you could potentially get the wrong answer, especially if it's a decimal or a fraction. So let's try substitution and see how that one goes. So I need to isolate one of the variables and plug it in for the other one. So I'm going to move that x in this one. I'm going to move x to the other side and just solve for y. You could also solve for x and plug it in for x. But whatever you choose. Okay, so y equals x plus 2. I'm going to take this and plug it in right here. So then I get 3x equals 2 times y, and y is x plus 2. I distribute my 2, combine like terms, move some things around. Hopefully you get the math so far, because I'm going a little bit faster. X equals negative 4. I need to take that negative 4 and plug it back in for x to solve for y. So I went back to this guy right here, plugged in negative 4. Negative 4 plus 2 equals negative 2. So my solution is negative 4 comma negative 2. So even though my lines were slightly off, those solutions do match each other. So I wasn't too far off. All right, then elimination. I need to get same number, opposite signs. So you could either make in this second equation, you could make the x negative 3 or make the y a positive 2. Whichever one you choose, totally fine. I just did the x's because it happens first, and the numbers were small enough that I didn't really care. So I multiplied by negative 3, and when that happens, I get negative, top one stays the same. Bottom one becomes negative 3x plus 3y equals 6. I can cancel things out, cancel that out. So y equals negative 2. And then I plug y back in for y to solve for x, and x equals negative 4. So my solution is negative 4 comma negative 2. Since all of these were the same exact equation, if you ended up getting different solutions, that means you probably made a mistake somewhere and you need to go back and fix your mistake. So just a tip for you, go ahead and try the homework section. Hopefully it's not too bad, but let me know if you have any questions.